Hello, my name is Ryan Kinchin. I'm with High Desert Math Tutor, and today I want to talk to you about factoring by grouping. So before we get into factoring by grouping, let's just do a quick recap. What is factoring, or what is a factor? So a factor is anything or any number that's being multiplied. When we say we want to factor something as a verb, we mean we want to take this object and break it into multiplication. Now, factoring by grouping is a method that is most often used to factor polynomials, such as this, or trinomials, when your leading coefficient is a number that's greater than 1. Now, more simple polynomials where the leading coefficient is 1, those work just as fine when we do factoring by grouping. So, getting into this, factoring by grouping, our goal is to take this middle term and split this into two smaller terms, typically smaller, that we can use to easily factor this or rewrite this as multiplication. So let me just give you a quick demonstration right here how we do this. So the first thing we do is focus on the leading coefficient and the constant term. We want to identify those, and then we want to multiply them and put the answer right here. So if you don't see a number in front of x squared, what number is technically there? Well, there's only one x squared sitting here, so the leading coefficient is a 1. So we're going to multiply the leading coefficient and the constant term. 1 times 2 is 2. Next, we focus on the coefficient in front of the x right here. So we want to ask what numbers will add up to 3. So our goal now is to ask what numbers can we multiply to get 2, but you add those numbers together to get 3. And you may realize those numbers are simply 1 and 2. 1 times 2 is 2. 1 plus 2 is 3. So what we're going to do now is take this middle term, we're going to split that into two smaller terms. So what we have is x squared is unchanged, plus, now we're going to say one single x, and two x's, plus 2. So notice, 1x plus 2 more x's gives you 3x. So we took this middle term and we split it into two smaller terms. The x squared term stays the same, the constant term stays the same. Now what we want to do is group some of these together. So let's group these first two terms together. We'll group the second two terms together. And we want to ask ourselves, are there any common factors within this first group that we can factor out? So x squared says that there are two factors of x sitting here. And there's another x right here. So we can factor out a single x. What would be left inside is x plus 1. We're going to bring down our addition sign. And now here we're going to ask, what common factors do these have in this group? Well, each of these terms has a 2, so we're going to factor out a 2, and we have x plus 1 left over from that group. Now, this is where it's a little bit interesting. This is new for many people. We're going to put some big parentheses or brackets around this now and ask, in this big term plus this big term, what do these two terms have in common? They each have a factor of x plus 1. So what we'll do now is we're going to factor out the x plus 1. So what's left in this term when we take away this x plus 1? There's just an x. What's left in this term when we factor out the x plus 1? There's just a 2. And finally, we've factored this trinomial completely into x plus 1 times x plus 2. So that's an pretty straightforward polynomial we could have factored by just trial and error, but we wanted to use this to show the process, first of all, of factoring by grouping before we get to a more challenging example. And also, we wanted to show that factoring by grouping works with simpler polynomials where the leading coefficient is a 1. Now, when the leading coefficient is not a 1, this is where factoring by grouping really shines. This is where it's very useful for us. So just like before, we're going to focus on the leading coefficient and the constant term. We want to multiply those numbers together and put the answer we get on top. So 6 times 3 is 18. Next, we want to look at the coefficient for this middle term, and we're going to put that on the bottom of the x over here. So the middle coefficient is 11, and we want to remember that that number is associated with addition. So now we ask ourselves, so this is trial and error. This takes a little time to get comfortable with. What numbers multiply up to 18 but add up to 11? Well, we can multiply 2 times 9 to get 18, and 2 plus 9 is 11. So now, again, this next step takes a little trial and error to get used to. We want to take this middle term and we want to split that into 2 smaller terms. Now you may wonder, how do I know that the 2 or the 9, which one comes first? That's what takes a little trial and error. So we'll go ahead and put the 2 first here. So we're going to first copy our 6x squared plus, from these 11 x's, we're going to take 2 of those x's and put them by themselves, plus we're going to take the remaining 9 of these x's and put them by themselves, and then we're going to copy over the constant term 3. Next, we want to do some grouping. So we're going to group the first 2 terms together. We're going to group the second 2 terms together. And then now we ask, what's the greatest common factor from the first group? So we have a 6 and a 2. Both of these numbers have a factor of 2 in them. Now onto the variables, we have 2 factors of x. We have a single factor of x. So we'll take out whatever they both have, which is a single factor of x. And if we take 2x away from this, factor out a 2 and factor out an x, we just end up with 3x from this term. In this term, we took the 2x away, so all that's left is the number 1. We'll bring down the addition, and now we repeat the process. We ask ourselves, what common factor do these terms have? So focusing on the numbers, 9 is the same as 3 times 3. We have a factor of 3 here, so we'll bring that out. Notice this term does not have a variable. That means we cannot factor anything else out. So we'll put our parentheses. If we take a factor of 3 away from 9, we end up with just 3x. If we take a factor of 3 away from here, we end up with just 1. So we're almost done with the factoring by grouping. The next step is to add either parentheses or some brackets. And now we have these 2 ginormous terms. This term, everything's being multiplied, so this goes together as one group, plus this term. These are being multiplied, so that goes together as a group. So we ask, what factor do both of these terms have in common? And as you can see, they both have a 3x plus 1 in common. So we're going to factor out of these brackets 3x plus 1. So now we have 3x plus 1 times When we take this factor away, all that's left is 2x. We'll bring down the addition. When we take the factor 3x plus 1 away, we're left with a 3. So now we're done factoring. So factoring by grouping, very helpful. It works in most instances when you can factor a polynomial with nice numbers that are whole numbers typically. This process can be slightly more challenging if you have negative numbers mixed in here. So I'll make another video soon that covers going over other more challenging factoring scenarios.